Assalamu alaikum warahmatullahi wabarakatuh, dear students. In this session, I'm working on hypothesis testing, and this is a practical session. I'm sure you have learned the basic concept and idea of hypothesis testing. So here we have Z and T test. I'm just teaching you how to use the Z and T test in Excel. These are test statistics. So first, I'm just giving you the concept when they are used. Very much briefly, the T statistic, this is used when the sample size is n, that is n is less than 30, and the population standard deviation that is unknown. And the Z statistic or this test that is used when the sample size is greater or larger than 30 in the standard deviation of the population is known. So very simply in Z statistic, this is an appropriate test whenever the standard deviation is known, which is used by sigma here. And here if the standard deviation is not known, then we are computing it. So that's the difference, the basic difference between these two tests. Okay. Now here, inshallah, I learn how we can use these tests in hypothesis testing. So in our situation here, we are working on a t-test. Okay. We have a scenario. A marketing analyst wants to test whether users stay on the website longer than 5 minutes per visits on average. A random sample of 12 visit duration is collected. Okay, your student here is a marketing manager or analyst. He's just interested to know whether the customer, when they visit the website, they stay longer than 5 minutes or not. Okay, very much simple, easy. So the 12 visit duration data is been collected by the marketing analyst. So you can see here the customers, 12 customers or visitors. And this is the time of their visits. Okay, very much simply. Now in hypothesis testing, first you should develop what are your hypotheses. We have two hypotheses. One is a null hypothesis, right, which is H naught. In this situation, we see the mean that is less than or greater than 5. Okay, and what is our alternate hypothesis? We see the mean that is greater than 5. Okay, very much simple, dear students. Okay, look, what the marketing analyst is interested to check and to test, and that is that he's just checking whether the customer stays more than 5 minutes. This is a claim. We call it alternative hypothesis. And where we have the equal sign, that's we say no, the customer, they are just staying 5 minutes or less. This is our null hypothesis. So now we are just checking and testing the null hypothesis to make sure using T statistic to whether we can reject the null hypothesis or we can fail to reject the null hypothesis. Okay, dear students. Okay, first we are using T statistic. Why? The reason behind, because I have explained that in T statistic the sample, the standard deviation is not known. So that is what we just try to find out first, the standard deviation, and also the sample size is less than 30. So that's why this example is more appropriate for T statistics. So first you should find out your mean value, and that is the average value. Okay, and this is the average minutes we have, that is 5.75, and the standard deviation, and you should use stdav.s because this is our sample simply. Okay, now dear students, once a mean is given, standard deviation is given, then for T statistic you must know the degree of freedom. If you're using the T table, or you can say the student T table, T distribution table, then you must have the degree of freedom. Okay, before degree of freedom, we must know what is the significance level. Okay. Okay, the significance level in our question here is 0.05. And what does this really mean? This means that we can only reject the null hypothesis if our confidence interval, that is, you can say our T statistic value is above the confidence interval around the H naught value, around the 5. What does it really mean? It means we just try to be more than 95% sure, right, in order to reject the null hypothesis. Okay, so if the confidence interval is 95%, so you can say the significance level, we can also call it alpha, that is 0.05. Okay, the next point is the degree of freedom. Okay, this is what I have already explained. The degree of freedom simply is the sample size minus 1. So the total sample size is 12 minus 1, that is 11. Okay, the next information is the critical value. Okay, dear students, what is the critical value? Okay, if you have a significance level in the degree of freedom, just go into the T, when you are using the T statistic, go into the T distribution table and just check what is the intersection value of 0.05 and 11. Okay, just come into the table of T statistic. So we have 0.05, this is the alpha, and the degree of freedom, this is in this column, we have a degree of freedom, and this is the alpha. So the intersection value is 1.796. So we have 1.796. 1.796. Okay, dear students, Once these informations are given, then you can manually compute what is the t-statistic. So I'm just computing t-statistic, or t-value. You can call it simply t-value. Okay, have to find it out, equal sign. Okay, and this t-value, what we have in the denominator, we have x bar minus mu. So the x bar value, this is our mean value. Okay, then minus what is the mu? This is the hypothesized value, which is the 5. This is the 5 is the hypothesized value, or the population mean, assuming the null hypothesis. So we have here, we in the null hypothesis, we have the value of 5 here. Okay, 5, and then you should divide it by standard deviation, which is s, right? So this is standard deviation. Okay, take this in bracket for more clarity. Okay, this is the standard deviation, and then this should be divided by square root of n. Okay, the square root of n value. This is n. Okay, very simple, dear students. Just press enter, you have a t value. Okay, now you are just checking whether you can reject the null hypothesis or fail to reject it. Okay, look here, what is the critical value? This is the critical value, and this is the t value. Keep in mind, whenever the t value is greater than, you can say here, since the t value, right? So you can say since the t value is greater than what? Is greater than the critical value, which is 1 point, or you can say, let me say the t value, which is 0.4518, right, is greater than critical value. Critical value in our situation here is critical value, which is 1.796. Okay, then we reject the null hypothesis. Very simply, dear student, this is the way. Once again, I'm just repeating it. Okay, when you compute this mean in the standard deviations, and you have two hypotheses, and then the significance level is very much required, the degree of freedom, and the critical values. Once all these informations are given, then you should use manually the t-statistic, and then find out the t-value, and then you should compare the critical value with the t-value. If the t-statistic value is greater than the critical value, we are rejecting the null hypothesis. Okay, what's the concept and idea behind? Okay, practically I'm just showing this through graph. Look, dear students, for example, this is our normal distribution t. Okay, this is t, and this is the, okay, this is the central value. You can say this is mean value. This is showing the mean value for, this is 0, or in our example, this is now 0, the standard value of 5 here. This is 5. Sorry, this value, hypothesized mean. And now the critical value is this is 1.7. So for 0.05% confidence, the confidence interval is 95%. So it's mean this is the 95% region. This one is the 95%. Okay. Okay, and this is the 5%. This region is 5%. So we say that if the t value that is significantly farther, this is far away from the central value, and the central value, so this is the 5 here, right, the null value. So it is too much farther, and it is farther, and it's beyond the confidence interval. You can say this is in the area of 0.05. This is in the area of what? 0.05. So we say if the t value that is just lying so much farther away, which is in the less than 0.05 area, then we are rejecting the null hypothesis. Why? Because we cannot accept the null hypothesis. The reason behind, because it is not in the interval. We are out. We are so much far away from the null, from the mean or the null hypothesis, from the hypothesized mean of the null hypothesis. Okay, dear students. Okay, what is the critical value here? The critical value, this is the critical value. In this point, we have a critical value, which is 1.79. This is the critical value, dear student. Okay. And what is the t value? This is our t value. This is the t statistic value. Okay, sorry, why the t statistic value is less? Okay, just a minute. Okay, I'm sorry, here we have done a little mistake. Okay, in this value, this is the standard deviation. Okay, this is the standard deviation. I have chosen this value. This is standard deviation, this value. Okay, why? Because in the function, in the denominator, we have a standard deviation. Just press enter. Now it's correct. Now it's correct. Okay, so you can see here the value is 4.3689. Okay, okay, dear students, look here. So when you compare the critical value, which is 1.796, then we have a t value which is 4.368. So we can say this is a critical value here, 1.79. So the 4 is just in this area, in this shaded area. It's mean you can say the p value here is less than 0.05. 1.79, this is the critical value, and within this critical value, or this is the boundary, you can say we're just comparing the t value. If the t value is above this region, right, in this critical region, then we are rejecting the null hypothesis. But if the t value lies in this confidence interval, then we cannot reject the null hypothesis. So we can say since the t value 4.3689 is greater than the critical value 1.796, then we are rejecting the null hypothesis, dear students. Okay, hopefully this is clear, but this was just manual. What if you just try to use the Excel? Okay, if you're not using the manual method,